Thank you, Lauren, for that wonderful introduction. Mahalo, everyone, for coming. My name is Kelly, and I'm a first year's master's student in the TCBES program here at UH-UO, and this is my tentative plan for my master's thesis, focusing on understanding the mutualistic relationship between invasive grasses and microplastic presence. It is no secret that plastic pollution has been a problem plaguing the world's environments. And with the presence of the Pacific garbage patch, this has made Hawaii extremely vulnerable to the effects of plastic pollution. And despite this urgent plastic crisis we are facing, recycling has become a challenge for residents in Hawaii. The Hawaii 5 Redeemable Plastic Bottle Program was created as an incentive to recycle, but the only plastics being accepted are types 1 and 2, which excludes all these other plastic types. In addition to plastic pollution, microplastics have become an established part of natural landscapes, being found in remote places from oceans to soils. Another pressing issue that the Hawaiian Islands are notorious for facing is the rapid arrival and spread of invasive plant species. As the increasing threat of climate change becomes more rapidly prevalent, invasives will continue to possess traits that allow for greater resilience, making these plants successful survivors. Amongst these invasive species are invasive grasses that have been introduced to the islands for agricultural use, which has increased the risk of wildfire, coupled with drought and less rainfall. These grasses are dominating native shrublands and forests that can outcompete, smother, and grow exponentially during dry periods, or during wet seasons, sorry. Amongst the 10 most invasive grass species in Hawaii includes Kikuyu and fountain grass. Fountain grass was initially introduced as an ornamental plant, but quickly began degrading the quality of pasture lands, and is also unpalatable to cattle, allowing for rapid spread. Kikuyu grass was also brought to Hawaii as pasture grass for ranchers, but rapidly spread, impeding on the cultivation of important crops. Both grasses are recognized as habitat modifiers and are actually listed high risk on the Hawaii Pacific Weed Risk Assessment Score. These grasses also have the tendency to smother native plants when unmanaged, can spread fire rapidly during dry periods, and is also potentially considered allelopathic. So how do these topics connect? There has been research demonstrating the connection between invasives and microplastic presence. Invasive species are known to create something called soil legacy, which causes lasting effects after removal that may prohibit endemic species from being replanted and successful in reestablishing their homes. Soil legacy can be defined as a lasting effect in the biotic and abiotic composition of the present soil that affects the current growth of plants within that community, and is a common characteristic that many invasive plant species possess. Microplastics have also been known to create soil legacy as well. For example, a study in Germany found that shape and polymer type had negative effects on soil aggregation, and intensity varied by shape, even though each microplastic was made of the same polymer type, which is polyethylene. It has also been found that microplastics influence plant traits negatively and positively depending on the species, showing that plastics have left a legacy and could aid in the success rate of invasive plant success. For example, another study found that shoot and root mass increased significantly with all microplastic shapes. However, a different study focusing on microplastic stress within plants found that plastic presence actually impeded on shoot and leaf growth. Therefore, it is essential for more research to be conducted to understand potential patterns microplastics may have on plant growth and how that varies by species. Varying shapes of microplastics are found to have adverse effects on soil composition and plant traits, but type of polymer is also important to note. Polyethylene is the most used plastic in modern agricultural practices and acts as plastic mulch, which is a layer placed over the crops to decrease moisture evaporation and weed growth, and is typically a single-use plastic. Therefore, the study aims to understand the relationship between varying polyethylene microplastic shapes, specifically films, foams, and fragments, contamination, and invasive Kikuyu and fountain grass in Hawaii. I will be comparing varying polyethylene plastic shapes as they affect soil porosity and water retention. Both grasses will be acclimated with each plastic type, as well as combined exposure of all shapes, since it is likely that all forms coexist in agroecosystems. After the grasses are exposed to microplastics by soil conditioning, physiology and soil composition will be assessed, and measuring leaf size and root, shoot, and growth. Based on the literature and adaptability skills of invasive plants, I expect soil bulk density and water retention to decrease, allowing for more growth of roots. More specifically, I expect roots to increase in size to account for a loss of moisture in the soil. I also expect shoot mass to vary based on plant species and shape exposure, but overall still have an increase as well. And I also expect leaf size to decrease as a reaction to microplastic-induced stress. As Hawaii continues to face loss of essential habitats and native species as a response to rapid spread of invasives, this research is essential to continue understanding future patterns of invasive success and how microplastic exposure may affect growth and survival. Thank you. Are there any questions? Yes.
Have you collected any preliminary soil samples to see if there's microplastics in them where these grasses grow on the island?
Not yet, but my plan is to collect like virgin soil, so it will be free of these contaminants, or go through a process of cleaning it before. Yes.
So you might have mentioned this, but how did you choose between the two? How did you choose to use those two particular grasses for this study?
I basically just chose 2 off the list of the most invasive grasses in Hawaii, and then they both grow in different environments, wet and more dry environments. Yes?
I think that it might be worthwhile testing some native plants as well in comparison. Or
I
why
think-
are you focusing on the invasive?
Because I want to focus more on soil legacy specifically, and that's more common in invasive plants. I think adding a native plant would be a great addition. It just, I think, would make my project a little bit more complicated for the time I have here. Any more questions? Okay, thank you.